Okay, this time we have factoring, so we're on to part 2 of the quadratic review. Factoring, in this case, we basically got all of the same kind of factoring problems. This is all going to be general factoring. So essentially what I'm going to do is I'm looking for this and I'm thinking about splitting it into 2 sets of parentheses. Remember, this is going to equal 0, so we don't need this part. So I know there's going to be an x and an x here. That's how I get the x squared in the problem. Now, how do I get the other 2 numbers to go in here? The rule for this is they have to multiply to give you the third term and add to give you this number in the middle. So I'm looking at numbers that multiply to give me 6. I'm thinking about 1 and 6, or I'm thinking about maybe 2 and 3. In this case, I'm going to go with 2 and 3 because 2 times 3 gives me 6, and 2 plus 3 gives me 5. That seems to be correct. Now I got to figure out what number makes just this part equal 0. Well, if x were negative 2, that would equal 0. Alright, so the other side is the same idea. What makes this equal 0? That would be negative 3. So it's really nice and convenient to just say your answer is always the opposite of this. So if this was plus 2, your answer is minus 2. Alright, let's take a look at the other one then. This one has a little bit of a twist to it because there's a negative sign in front of the x squared. Remember that it's going to be equal to 0. Okay, no big deal. I can do it if I don't have that negative, so how do I get rid of it? I divide by negative 1. That's going to give me x squared, which is what I want, minus 4x minus 5, still equal to 0. And so now that this is a regular x squared, I can factor it pretty easily. And it's going to be x and x. Again, 2 numbers that multiply to give me negative 5, and at the same time add to give me negative 4. I think that's going to be negative 5 and positive 1. Sometimes you just got to think about that and try a few until they work. So this means positive 5 is an answer, and negative 1. Yep. Let's just keep going, because these are all the same thing. Here again, there's no negative or anything here, so we can just go ahead and do normal factoring. Got an x and an x. 2 numbers that multiply to give me negative 20, and add to give me just a 1. Well, when you think about 1 and 20, that's factors of 20, but that's not going to work. Because I can't put 20 and 1 together no matter how many ways I change the sign to get just 1 as an answer. Same thing with 2 and 10. But if I do 4 and 5, well, you have to think to yourself, wait a minute, I think if I had 5 was positive and I subtracted 4, I could get 1. So does that work? If 5 is positive and 4 is negative, 5 times negative 4 is negative 20. 5 plus negative 4 is 1. That's correct. Negative 5 and positive 4 on my answer. So let's take a look at this one. This time, once again, it'll be equal to 0. But we have a negative here, so we're going to divide that negative away to get x squared plus 6x plus 9 equals 0. And again, although this one can be done a different way, still saying x and x. 2 numbers to multiply to give me 9 and add to give me 6. Well, first thing that comes to my mind is 3 and 3. So this one is negative 3, but so is this one. So really you have the same answer for both. So really this time you only get one answer. Alright, so if general factoring doesn't work, then you get what we did in section 5.4, which is called completing the square. And I put 5.5 with this because if you happen to get an answer that deals with a square root of a negative somewhere, you're going to be doing the stuff we learned in section 5.5 about imaginary and complex numbers. So really, these two things kind of go together. Um, so, most of the time we want the problem equal to 0, but it's oftentimes kind of hard to factor it like that. Like for instance, this one here is very hard to factor. So instead, what we're going to try to do is turn the left side of this thing into something called a perfect square trinomial. It means that it has a perfect square in the first term and a perfect square in the third term. Or in other words, it's just like this, where you get something times itself to get this thing here. So that's what we're trying to do with this. And the way you do that is by completing a square. This is e over 2 squared. So for number 90, what I'm trying to do is figure out the number that goes in here. I'm going to use this to do it. So b is 10. I got 10 over 2 squared. So that's 5 squared, which is 25. So I'm going to write a plus 25 here, but I got to write it over here also. Because if I add something to one side, I have to add it to the other side too. So really I have x squared plus 10x plus 25 equals 45. Alright, so the reason you do that is so you can factor this in a perfect square trinomial format, which looks like this. You're going to square root the first term, take the sign of the middle one, and square root the third one. Like that. When you get to this step, notice that if you could get rid of that square, you'd be down to just an x plus 5 from all of this. So to get rid of the square, use square root. It will cancel that out. And so we have x plus 5 equals the square root of 45. So I'm going to simplify that square root of 45 over here on the side. I'm looking for the biggest perfect square that goes into 45. In this case, it is 9. 9 times 5. Square root of 9 is 3. And square root of 5 is left over. So my simplified version of this is plus or minus 3 square root of 5. And finally, I need to get this plus 5 over here to go away. So I'm going to subtract 5 from both sides. There's my x. Now, you can't add a number and then a square root term together. So you just write the number in the beginning, and then the plus or minus. Forgot. Really going to erase that. Plus or minus 3 square root of 5. And this is your final answer to this one. So it looks kind of like a long process, but a lot of you did really well on the test on this, so I think maybe you finally gotten the hang of it, because you notice that it's basically the same thing over and over. Alright, if we look at number 91, notice that there's already a number here, but again, we don't want whatever number they gave us. We want to put our own number in there, the correct one. So this is a minus 23 that has to be added to the other side. So now I'm going to figure out what goes in there. So using b over 2 squared again, this is now negative 6 over 2 squared. That's going to be negative 3 squared is 9. So I'm going to put a 9 here and here. So I end up with x squared minus 6x plus 9 equals 32. Okay, so here we are again with, now we're situated, we're ready to do perfect square format for factoring. This is x, minus signs in the middle, and square root of 9 is 3. Alright, now again I want to get rid of that square, so I'm going to square root it. So that cancels, and I'm left with x minus 3. And here again I have a square root of a 32, which is not an easy square root, so I got to simplify it again. In this case, 16 is the biggest number that goes into that one. So we're going to get 4 square root of 2. So I know that this is plus or minus 4 square root of 2. And I'm going to add 3 to both sides. Again, I don't add it to the square root term, so I put it first, and then I put the square root term second. And that is the final answer. Alright, so keep going with this. Again, this more completing the square. So minus 14, because we don't want that number there. X squared plus 6x, negative 14 over here. I want to do b over 2 squared to come up with that new number. B is 6, so I got 6 over 2 squared, that's equal to 9. So I'm going to add 9 here, and here. Got x squared plus 6x plus 9 equals negative 5. In a perfect square trinomial factor this, x plus 3 and negative 5. Now I'm going to square root both sides to cancel out that square. And I got x plus 3 equals the square root of negative 5. Well, that doesn't simplify as far as the number, but that negative needs to go away. So we're going to end up with a plus or minus square root of 5. And because it was negative, now I'm going to write an I out here for the imaginary numbers. I'm going to finish by writing subtract 3. Again, that number gets written first, plus or minus the square root of 5i. This time we get a complex root with both real and imaginary parts. But otherwise the process is very much the same. Number 93, the last of the completing the square, then it's going to subtract this 3 out. Going to do b over 2, negative 2 over 2 squared, that's equal to 1. So plus 1 here, plus 1 here. X squared minus 2x plus 1 equals negative 2. And my perfect square trinomial factor, x minus square root of 1 is still 1. And I square root both sides to cancel the square. X minus 1 equals square root of negative 2. Again, I can't do anything with a 2, but I can bring that negative out by putting an I here. Add 1 to both sides. That 1 goes first. Square root of 2 with an I. Again, another complex root. So we come to these last set of problems, which are in the perfect square trinomial and completing the square section, but it's only, I think, to kind of make you think you have to do that when you really don't. If you just look at this problem, you notice that there is no x term here. It's just the x squared, and that's it. With one variable term, they're really easy to solve. You treat it just like a regular algebra equation. If this was just an x instead of an x squared, everybody would say, oh, I just subtract 14 and divide by 3 and I have my answer. You basically do the exact same thing. Subtract by 14. Divide by 3. Except your stuff here, well, to get rid of that square, all you got to do is square root it. And now we got square root of negative 11. Can't do anything with the 11, but I can pull the negative out by putting an I. Same process over here. Look, I've got to subtract 81. Divide by 3. Square root. Okay, now what do I got to do with this negative 27? I know there's a negative, so it's going to be an I. I know there'll be a plus and minus. The question is how do I simplify the square root of 27? I'm doing this on the side over here. The biggest perfect square root within the 27 is a 9 and a 3. That's 3 square root of 3. That goes with. Okay, this one is done.